Okay, so up to now we've been doing some factoring of trinomials, our quadratic equations, and all the factoring that we've done till now has been when the leading coefficient, or the number in front of the v squared, has been 1. But as you can see here, it has a coefficient of 2. So we solve these equations a little bit differently when there is a number larger than 1 in front of that v squared. Oops, hello. Let's see. So today is 5, 7, 14, and we're going to take this equation here, 2v squared plus 9v plus 7. Now, this number is higher than 1, because normally we would just factor it like this, and we know that this is v here, but this has to multiply to 2v squared, right? And then we got to do the factors of 7, and then we got to get them to add to the 9. It's a little bit harder when you have this leading coefficient, so there's a little trick to getting this, and this is what we do. So when you have a number here larger than 1, we take it and we multiply it by the last term, which gives us 14. So then we take 14 and we try to figure out which terms of 14 will add to that negative 9, or add to that positive 9. So in this case, we know 2 times 7 is 14, and we also know when we add them, we'll get 9. So what we're going to do is we're going to rewrite this equation. So we have 2, I wonder if my head's in the way. Let's do this over here. So we have 2v squared. Then, instead of writing 9v, I'm going to take these two factors and replace 9v with 2v and 7v. So I'm going to plug in 2v and 7v. And then I keep my 7 in there still, like that. Okay, so all I did was I multiplied the leading coefficient with the constant. I got 14. Then I figured out which two numbers will multiply to that 9v, and I didn't change the value of all because 2v and 7v is 9v. So now from here, I want to factor these separately by grouping. So I'm going to group these first two together and these second two together. Okay? And then just like we did a couple weeks ago, we're going to find the GCF. So when I look at this part, I'm going to look at it separately. I want to see what will go into 2v squared and 2v as the GCF. Well, they both had 2, and they both have a v. So 2v will be my GCF, and then 2 divided by 2 is 1, and v squared, remember over the v to the 1, we subtract that, and that will give me v. Bring my plus down, and then 2 divided by 2 is 1, and then the v's cross off. Okay? So I just factored that part. Now I bring my plus down. Now I want to find the GCF of 7v and 7, which is obviously just 7. Okay? So I bring my GCF out front. 7 divided by 7 is 1v, or just v, and then 7 over 7 is 1. You know you've done this right if your two parentheses match. Okay, so that's an indication you did it the correct way. So then I'm going to take my two GCFs here, 2v and 7, and put those in one parenthesis. And then I'm going to take my match and put them in one parenthesis. And then this will equal this. Okay, if I multiply this out, 2v times v is 2v squared. 2v times 1 is 2v. 7 times v is 7v. And 7 times 1 is 7. And so that would give me 9v. And so that would give me 2v squared plus 9v plus 7. So I know that's right. So I'm going to go ahead and put in my 2v plus 7. And then I'm going to put in my v plus 1. Okay? And you may wonder why we only wrote this one time. It's because basically you're factoring out a GCF of v1. And then when you divide it by v1, you get the v1. So we only bring one of these down here. All right? So let's try another example. Secret message, LCS rocks. Secret message, LCS rocks. Secret message for today. All right. So again, I'm going to take my equation here. okay? So again, I have a leading coefficient bigger than 1, so I'm not going to be able just to do 2 parentheses and multiply the last, okay? Because if you think about it, the factors of 11, you're not going to be able to get them to add to 13, and then you got to deal with that too. So just like we did before, we're going to take the 2 and the 11 and multiply that, and that's going to give me 22. And these first ones are pretty easy. So what are the factors of 22 that will add to 13? 2 and 11, right? 2 plus 11 is 13. 2 times 11 is 22. So now we're going to take this and rewrite this equation, 2u squared, and then instead of 13u, I'm going to put in 2u and 11u equals 11. Okay? Then we do grouping of factoring. We're going to group the first 2 together, and we're going to group the second 2 together. Okay? I'm going to treat this as a separate problem. I'm going to say what goes into 2u squared and 2u for our GCF, and you guys did a really good job in this class. That's 2u. So we bring out the 2u, and then 2 divided by 2 is 1, and then u squared over u. Remember, you subtract those. That would just give you u. Bring your plus in, and then 2 divided by 2 is 1, and then the u's cross out here, so we have 1. Okay? Then we have this plus here, so we bring our plus over. Now we got to find the GCF of 11u and 11, which is fairly simple. It's 11. So we bring out our GCF here, and then 11 divided by 11 is 1u. Bring your plus down, and then 11 over 11 is 1. Okay? Then I look at these 2 match, so I know I factored correctly. And so my final answer is going to be my GCFs in one parenthesis, so that's 2u plus 11, and then my matchers in the next parenthesis, so that's u plus 1. Okay? And then I know I did it right. I know this is a little bit confusing, but we're going to work on it more in class tomorrow. But basically the key difference here is identifying that you use this method when this is not 1. I mean, everything we've been doing up till now is just u squared, you know, plus 2u, you know, plus 4 or something like that, where this is 1. All these have a number of 2 or higher. So when we do that, we multiply that a coefficient, right, the coefficient a, 2, times 11, and then factor those out by grouping. And we'll work on this a little bit tomorrow. Okay? Have a good night.